In this video, we're going to learn how to determine if a matrix is invertible or not. So to me, the right way to think about invertibility is to think about linear transformations. So let's suppose we have a linear transformation from, say, Rm to Rn, and we can call it T. So we want to know if this linear transformation is invertible. So we want to know if we can find a map going the other way, which if it exists, we would call it T inverse, that undoes what T does. So in other words, if T sends a vector V from Rm to W in Rn, then T inverse is going to take that W and send it right back to where it came from, namely V. So if we want an inverse to exist, we need to know what's going to happen to every element of Rn. So in other words, every element of Rn has to be mapped to by something in Rm. And if I rephrase what I've just said, we said that T has to be surjective. So to have any hope of an inverse existing, I have to have somewhere to send everything in Rn back to. So it had to be mapped to by something from Rm by T. So the other issue that could happen is I need to have somewhere to go back to, but one thing that could go wrong is if I have choices of where to go back to. So if I have two things in Rm that T maps to the same place, then I don't know where I'm going to send the thing from Rn back to. So what we need to happen is T needs to send different vectors to different places. And what I've just said there is that T has to be injective. So if we want a matrix to be invertible, the corresponding linear transformation must be bijective. I want to make one quick note before we look at an example. So note that when I say T has to be surjective, that tells us a little bit about M and N. In particular, it tells us that M has to be at least as big as N. If the dimension of our domain isn't big enough, we won't be able to fill up all of the codomain. And we also know something from T being injective. If M was bigger than N, then we could not be injective. We would have to squish something down to fit it inside of our N. So we know if we are surjective, M better be at least as big as N, and if we're injective, it can't be any bigger. So if we're bijective, M and N have to be the same. So in terms of matrices, the only matrices that have any hope of being invertible are square matrices. So let's look at an example. So if I don't write down a square matrix, this is going to be very easy, so I'll write down a square matrix. So here is a 3 by 3 matrix corresponding to a map from R3 to R3. And we want to know if it's invertible or not. So the question we're asking ourselves is the corresponding linear transformation bijective? Well, the way we answer that question is to look at the reduced row echelon form of A, which in this case I have typed in a calculator, and it has produced the identity matrix. And so in particular, we have a pivot in every column, so our map is injective, and we have a pivot in every row, so our map is surjective. So our linear map is bijective, so our matrix A is invertible. In the next video, we'll talk about how to actually find the inverse of A once we know that it's invertible.